This video contains footage that I made for a different edition of your book. As is often the case with textbooks, most of the numbers and examples are identical. The only difference is the name of the section.
All right, good people, this is day 2 of the complex numbers, section 2.4. So what we're looking at here in this first example is just really combining like terms, pretending like I is a variable. I know it's really a number, but you can just combine these two to get 12. And then negative 1 plus 2 is positive 1i. And there it is. Number 15, very similar. Just make sure you remember to distribute the subtraction. This is going to be negative 4 and negative 3. So 9 minus 4 is 5, and 2 minus 3 is negative 1. Number 16. Very much like foiling. So firsts would be 2 times 3, which is 6. Outsides would be 2 times I, which is 2i. Inside would be 3 times 4, which is 12i. And last would be 4i times I, which is 4i squared, which is actually going to be 4 times negative 1, which is negative 4. When you add these all together, you can combine some like terms, and you get 6 minus 4, which is 2, and 2i plus 12i, which is 14i. This looks like something that you can do. Notice that you are adding conjugates here, 4 plus 5i and 4 minus 5i. But you still combine all the like terms that you see to get the answer. Here we're going to distribute. That also works with i's. Distribute, you get 8i plus 6i squared, and that becomes 8i minus 6, because I squared is negative 1. So rewriting this in kind of a more familiar format, we get negative 6 plus 8i. And that is the answer. Here, we've got 5 minus 5, which is 0, and 6 minus 3, which is positive 3i, which you can say is the answer. That's 3i. Now, factor. Here is like the big reason why we have i's. The one reason why i's were invented in the first place was because you can factor this now. Now normally, if you had seen x squared minus 4, you could say that that was x plus 2 and x minus 2. And if you learned your algebra well, then you know you can't use real algebra to factor this because it's plus. What you really need is minus. Well, we're doing something more complex than real algebra. We're doing imaginary algebra, complex numbers algebra. So what you can do is you can force there to be subtraction. X squared minus negative 4. X squared minus negative 4. You're forcing the subtraction. Then you have to ask yourself, what times itself is x squared? And you say x. And then what times itself is going to be negative 4. And until now, you had no way of taking the square root of negative 4. But now, you can take the square root of negative 4. It becomes 2i. Because 2i squared, that becomes negative 4. So therefore, the square root of negative 4 is 2i also. What this becomes is, you've got a plus b times a minus b. It's the difference of squares. That's basically going to be x plus 2i times x minus 2i. And finally, we can find two factors to this expression. Let's do that again here. I'm just going to rewrite it so that it's a little more familiar. No real need to, but I want to just because it looks prettier. It looks more familiar to me. I'm going to force there to be subtraction. And I'm going to forcibly take the square root of negative 9. That becomes 3i. So I can say that this is y plus 3i and y minus 3i. Because the square root of negative 9 is 3i, which is what you're using. That's the answer, 21. Next, determine whether 1 minus I is a solution of this equation. Well, if you want to determine if it's a solution, then you plug it in and see if it works. Let's see, we've got 1 minus I squared minus 2 times 1 minus I plus 2 equals 0. Is that a solution? Is it correct? So 1 minus I squared, that's just going to be 1 squared, which is 1, minus 2I plus I squared. I'm going to distribute. And we're wondering if that's all equal to 0. Well, this becomes 1 minus 2I, and then plus I squared, which is negative 1, minus 2, plus 2I, plus 2. Is that equal to 0? Well, I do see some like terms that are going to cancel out. So, yes, 0 is in fact equal to 0. Yes. The answer is, it's a yes or no question, so therefore the answer is yes. Find x and y given that this all crazy mess has got to be true. Well, what I can do is I can distribute. I think that might be a good first step. And we get 3x plus 1 plus iy plus 2i is equal to 2x plus 2yi. I'm going to just move everything over to the other side to help combine like terms. And so then what I get is, I get 1x plus 1 plus negative 1 yi plus 2i is equal to 0. If that's all going to be true, then what you can do is you can separate it out into the real components and the imaginary components. If all this has got to cancel, then the real part we can actually separate it into its own equation. We could say that x plus 1 should equal 0. And then the imaginary part should also equal 0. Negative 1 yi plus 2i should also equal 0. I know that it looks a little messy, but what you can do is you can divide both sides by I and just say that negative y plus 2 is equal to 0. And so therefore y has got to equal 2 and x has got to equal negative 1 in order for the equations to cancel. So here are some conjugates. Examples of complex conjugates are right here. Notice 3 and 4. 3 plus 4i and 3 minus 4i. 5 minus 7i, 5 plus 7i. Negative 3 plus 6i and negative 3 minus 6i. The only difference is that the b values are opposite of each other. They're getting subtracted instead of added, or the other way around. So the conjugates here would be 7 minus 2i. And here would be 6 plus 4i. Again, we have the opposite imaginary value, so the b value, when I say b value, it should be a plus bi. 5 is the b value, so we're going to take the opposite of that. The conjugate would be 5i, and this would be negative 3i. The conjugate of negative 3 is actually still negative 3. You can think of it like this: negative 3 plus 0i, negative 3 minus 0i. In any case, negative 3 is its own conjugate. And the same thing for 8. 8 is its own conjugate. So now we're going to use the conjugate. If we want to divide these two numbers together, it's going to be kind of difficult to divide, but what we can do is multiply by the conjugate. 3 minus 2i. The conjugate is a way of getting square root of negative 1, or I, out of the denominator. Now when we multiply by the conjugate, we're going to see that this becomes 3 squared plus negative 6i plus positive 6i times, or let's say minus 2i squared. We don't even need to really figure out what those middle terms are, because when you FOIL conjugates, you're just going to get first term squared, last term is a square, and there's going to be the same. So this is 9 plus 2i squared is 4 times negative 1, so it all becomes positive 4. This is still going to be 1 plus 3i and 3 minus 2i. I think what I'm going to do is I'm going to FOIL this, and so you can see FOIL. First terms would be 1 times 3, which is 3. Outside terms would be negative 2i. Inside terms would be positive 9i. And last terms would be negative 6i squared, which is, I'll just write it out, negative 6i squared, which is equal to positive 6. When you combine those like terms, you get 9 plus 7i all over the 9 plus 4, which is 13. And if you really wanted to split it up and be kind of a complex number purist, it would be 9 over 13 plus 7 over 13i. You've got the real part, and then you've got the imaginary part combined together. A plus bi would be 9 over 13 would be a, and then 7 over 13 would be b. Here, again, multiplied by the conjugate. Conjugate is 3 plus 2i. 3 plus 2i. Conjugate of the denominator is 3 plus 2i. Well, this conjugate looks really familiar. I just did it, so we can see that this is the inside and the outside terms are going to cancel. Really, in the denominator, it's just going to be 3 squared, which is 9, and 2i squared, which is negative 4. So minus negative 4 would be plus 4. And at the top, this is 2 plus I times 3 plus 2i. First terms would be 6. Outside terms would be 4i. Inside terms would be 3i. And last terms would be 2i squared. Remember that you can combine like terms. Combining the like terms, you get 4i plus 3i, which is 7i. And 2i squared turns into negative 2, so 6 plus negative 2 is positive 4. 4 plus 7i all over 13. And if you break it up into a plus bi format, it becomes 4 over 13 plus 7 over 13i. What is the reciprocal of 3 plus 4i? Well, I'm not going to do the whole thing. This video has gone on long enough. We've got 3 plus... The reciprocal would be 3 plus 4i. Now, that is true, it is the reciprocal, but we generally try to not have any i's in the denominator, so you can have 3 multiplied by the conjugate, 3 minus 4i, 3 minus 4i, and then you can finish it later if you want, but that's how you would start it. I'm just going to leave a note and saying this is unfinished. And that's okay. Solve. So what we're going to do is we're going to gather all the x terms over here on the left-hand side of the equation, and all the non-x terms on the other side. That's going to be the immediate goal. I think the first thing I have to do is distribute. So we have 3 minus 4i plus 2ix is equal to I minus 1x plus ix, distributing both the subtraction and the x. Okay. Now remember that our strategy is to get the x terms on the left-hand side and the non-x terms on the right-hand side. So therefore, you should add or subtract this. We should add 1x to both sides so that we move it to the left. We should subtract 3 from both sides to move it to the right. Add 4i to both sides to move it to the right. And then subtract 1ix so that we can move it to the left. And when we do that, we get this. 1x plus 1ix is equal to 7i minus 3. Everything else cancels. By the way, here's your audio check. Do you know that leap year comes once every 4 years? That's right, people. Leap year once every 4 years. Then, as the next step, you can factor out the x. X times 1 plus 1i is equal to 7i minus 3. Dividing both sides by 1 plus 1i, you get set x is equal to 7i minus 3 over 1 plus 1i. Now that would be the answer for x, except we can simplify it. We can simplify it by multiplying by the conjugate. And when we do that, we get the two numerators multiplied by each other and the two denominators multiplied by each other. And you get 1 minus I squared on the bottom. Remember, that's the difference of squares, which simplifies to 1 minus I squared. I squared is negative 1, so 1 minus negative 1 is 2. First would be negative 3. Outside term, I'm foiling. First term would be negative 3. Outside term would be plus 3i. Inside term would be plus 7i. And last term would be minus 7i squared, which is the same thing as plus 7. Plus 7. Combining terms, we get 4. Negative 3 plus 7 is 4. And 3i plus 7i is 10i over 2. And lastly, simplifying, that's 10i. And factoring out a 2 from both terms, it's 2 plus 5i. Because remember that 4 plus 10i is the same thing as 2 times 2 plus 5i.
And because they're both over 2, then we can cancel the 2. And this is what we get. 2 plus 5i. Those are the notes. You can begin assignment 2D2. That means copy the problem list and do the first problem. I will see you all in class. Take care.